Counting, summing, finding the min or max value is quite frankly one of the most confusing aspects for people new to Convex. Before I became an official Convex fanboy, I flagged it as one of the things that I really don't like about Convex when I first encountered it. This is more a technical issue, but there are no aggregate queries in the database, so this means that it's not possible to count the number of items in a query without explicitly iterating them. If you are like me and you come from the SQL world, then you're probably used to doing something like select count star from some table, but no such thing like this exists on Convex. Why? Why on earth not? Well, I did just do a whole video on the why of that, so you might want to check that one out first if you want to dive deep into that particular question. But the too long didn't watch is that to perform aggregates such as count or sum, you kind of have to scan all the rows in the database, which can really cause performance issues as your data grows. So Convex kind of takes the philosophy of forcing you to think upfront about how to manage those aggregates yourself. In the solution section to that video, I briefly mentioned that you could use something called the aggregate component to help out. And I said if people want to have more information upon the aggregate component, then leave me a comment down below. Well, the people have spoken. So if you were one of those commenters, or you're somebody who's looked at the aggregate component before and noped out of there, or you're totally new to Convex and have no clue what I'm talking about, then this is the video for you. We're going to go through how to get started with it, how to do some basic aggregations like counts and sums before progressing on to some more advanced use cases. Then if we have time at the end, we're going to talk a little bit about how it works underneath the covers. Oh, and do stick around to the end, as I'm going to give what might be a bit of a spicy take on all of this. So once you've dropped me a like and sub, let's get into it. All right, so I'm going to assume that you have a Convex project already running. If not, check out one of the quick start guides for how to get started there. Then you're going to want to install the aggregate component with npm install @convexdev/aggregate. And then you're going to want to tell Convex how to use the component by creating a convex.config.ts file in your Convex directory and popping in something like this. Note here, it's a bit more complicated than you would probably typically have it. For this video, we're going to be using the same component multiple times with different names, so it allows us to easily identify the component within the Convex dashboard. Right, now you've got the component set up, let's have a look at how to use it. So let's imagine we're going to build a game that is going to show a leaderboard, something like this. So here we want to show the player name, their score, and rank. Oh, and by the way, if you want to try out any of these demos that I'm going to show in this video yourself, they're all available in the example folder in the aggregate component repo. I've left a link to it down below. Anyways, hopping back into the code, the first thing we need to do is define a normal Convex table for recording our scores in our leaderboard like this. And then, of course, we're going to need a mutation, a way to insert our score into the database. So here we define our add score mutation, and we push a record into our leaderboard table. All right, so now the question is, how are we going to display a page of data in our leaderboard table? I guess we could do something like this. Here we use the .collect function to grab every single row in the table. We sort them, and then we just slice off a page of items. And this would work, but as you've probably already guessed, this isn't going to scale too well as we get thousands, tens of thousands, millions of scores added into our database. We have to read every single row just to get back one page of results. What we kind of want to do is something a bit like this. Here we're trying to order the scores by descending, skip to our offset, and then take just what we need. But as you may have noticed, there's some red squiggles here because Convex doesn't have an order by or a skip. Well, Convex does kind of have an order by if you use an index, but it definitely doesn't have a skip. And related to this issue is the one of how we go about ranking our scores. So just think about this for a second. How would you go about efficiently ranking these scores? Say I add another score here, let's say Mikey C with a score of 9999. Well, how am I going to determine my rank? Well, I guess as long as the table's sorted, I could loop through all the scores until I find the one that I'm above, and that's my rank. But this doesn't sound very efficient if we're going to have millions of scores in the database. That could be millions of scans just to find out what rank I am. But then the issue is I'm going to insert myself into the position here and give myself a rank, but then everybody below me is going to have to then move down one slot, which is going to cause a lot more mutations into the database. This really doesn't sound very efficient, does it? But fear not, as this is precisely where the aggregate component steps in. So now let's define a table aggregate at the top of our file like this. Here we tell it that we're going to want to sort by the score from the leaderboard table, and it's going to be a number. Note that we are using a negative value here because the aggregate component by default sorts its entries in the ascending form. So that's from the smallest to largest. But we actually want to sort in the descending form, so from largest to smallest. So by negating the score here, it kind of does that. It'll make more sense in a minute. So now when we insert a new score, we must also remember to insert it into the aggregate component like this. For now, we're going to assume that there's no existing scores in the table, and we'll talk a little bit later about what happens if you have a table with existing data in it. So now we're inserting data into our leaderboard table and our aggregate component. We can update our paging query to look like this. So it's pretty simple. We're going to use the aggregate components.at function to find the score that is at the given offset in our page. So once we have that first item in the page, we can then use the .paginate function to define the lower bound that we're going to paginate over and the page size as our number of items. And once we have that, we can then go through each of those items in the page, look up in our own leaderboard table, the document, and return the results. Cool, so let's try it out. We have our first 5 scores here, and we can flip through the pages and the scores go down and everything feels nice and snappy. We can change the number of items that we want in a page, and it all just works. Awesome. And up here, we can add another score, and it should be entered into the right place. Cool, and we can remove some entries, and it all just updates nicely. Okay, so I guess what we've done here is to say, what is going to be the given score for this particular rank we're interested in, right? So as long as our leaderboard scores are ordered in a descending form, we can just grab 5 or whatever items and just show them. And this kind of makes sense, right? You can see how this would be slow if we were to do this without the aggregate component. Like for page 100, for example, we would have to manually scan through 496 other rows if we wanted to get just that page that we were interested in. And this would not only be just slow, it would also be really problematic due to the way that the transactional nature of Convex works. So like if any of those 496 rows that we scan through change, then it's going to invalidate our page. And so just even a simple name change would cause the row to be validated, which causes our query to be invalidated. And yeah, it could get expensive very quickly. So the way that the aggregate component works is it stores the data in such a way that allows us to skip lots of those document reads and get right to the part that we are interested in. But I'm getting a little bit of ahead of myself here. We're going to talk about how the aggregate component works a little bit later on in this video. But for now, let's just see what else we can do with the component to help us out. So now let's say that instead of wanting to look up a score from a given rank, we want to do the inverse of that. We want to find out what rank I would be given if I had a specific score. So we can do this really easily with the index of function on the aggregate. Oh, and not forgetting to invert the score, as we're actually storing our keys in inverted form in an aggregate that we've talked about before. And now if we take this for a spin, we can enter a score here and we get the correct rank. And again, this is reactive, just like everything in Convex. So if we add new scores or remove them, then it's instantaneously reflected. And finally, what happens if we wanted to get some stats on a particular player, like find out what my average score is or my highest score? Well, we can do that pretty easily if we pull in another aggregate. So now we've changed the sort key from being just a score to being this array, this tuple of the name of the person who got the score and the score. So it's first sorted by the name and then sorted by the score within that name for that person. We could also potentially do this using namespaces, but we'll talk about namespaces in a minute. We've also added the sum value here, which is going to sum all the scores up and cache them inside the aggregate component, as you will see in a minute. Okay, so then to show the average score for someone, we can do this. Here we use the component to count the scores belonging to the player and the sum of the scores, and then just returning the average from that. And don't forget, because of the way the aggregate component stores these values, this lookup is super fast and efficient and doesn't have to scan all the rows. If we want to show the highest score the user's ever gotten, then we can use the max function like this. Once we have the item, we can pull off the sum value. This maybe should be called max value, but anyway, it's called sum value. Okay, let's take this for a spin now. So I can enter my name in here and cool, it works. I can see my average and highest score. And of course, if I change it or add something else, then it's going to update. Awesome, love it. All right, so far so good. What else can we do with the aggregate component? Well, if you know that your data is going to be clearly separated, like the albums in this photos demo here, then you can use namespacing to more efficiently segregate your data, because this is going to reduce the amount of reads and writes by just segregating it by namespace. So when you define your aggregate at the top, just tell the component what namespace we're going to be using for this given document. Then you can use that namespace when calling into the component. So here you see we have a query that is going to get the number of photos in a given album. And by using the namespace, it means that if somebody adds a photo to another album, then it's not going to cause this query to rerun. We could also use the aggregate component to do efficient randomization like in this demo. So we can click this button to get a new random song. Or we can show a page of randomized playlist. To do something like this, we need to use a null as our sort key. And basically what this is going to do is it's going to cause the component to order the values in its structure by the ID of the document, which is effectively random because it's a GUID. Then we can use the .random function to efficiently get some random song. Now the final demo here is showing various stats that we can get from the aggregate. We can add values here, and you can see that the numbers change as I add more latencies. And this one is demoing a lower level API called the direct aggregate. So with this one, we don't actually tie our aggregate to any specific table. Instead, we're going to tell it what our key and value is directly. So this is the mutation that you would call when you wanted to report a latency. So here we insert with a key of our latency. Our ID is just anything. And our sum value is our latency. We're going to add up our latencies to get our sum. And here's how we return that data to the user in the query. We're using our count, we're using our sum, we're using our min, max, combining it all together to get a bunch of stats. And then we can just show that on the client. Easy. Okay, so before we pop the hood of the component and work out how it does its magic, let's talk about a couple of issues that you might encounter with the aggregate component. Now, you may have noticed, what should we call it, an operational issue when working with the component. Whenever we add a document into a table like the leaderboard here, we must also remember to add it into the aggregate. And the same goes for when we remove something or when we update something. We always have to remember to update the aggregate component because the keys and values could cause it to get corrupted or out of sync if we don't. This required coupling is necessary, but it is also very error prone. If you or one of your teammates forgets to include the aggregate component line somewhere, then you can easily end up with an aggregate component that's out of sync or corrupted. Fortunately though, there is a solution to this problem in the form of triggers and custom functions. Triggers, if you're not familiar with them, are a library that's provided by the Convex Helpers repo and allows you to wrap your database so that whenever you make a change to it, it can also trigger something else to happen somewhere else. I'll show you what I mean. So here we're going to create our triggers object by registering it on our leaderboards table and then attaching both aggregates like so. We can then pull in the custom functions library from the Convex Helpers repo, as it's going to allow us to write a custom mutation that looks like this. We can then go ahead and replace our mutations in here with our mutation with triggers custom function. And then we can go ahead and remove all those lines where we were having to update or insert into the aggregate, because our triggers are now going to cause the aggregate component to be automatically kept in sync whenever we make a change to our leaderboard table. And this is really nice as it allows us to massively simplify our code and remove that error-prone nature of our aggregate getting out of sync from our table. All right, so let's just make sure this all works by taking it for a spin. Cool. Yep, I can add, remove, update entries as before. Very nice. Now, as we are talking about issues, there is one other issue with the aggregate component that I should point out that might bite you if you're not careful. So, as you're probably aware, every single Convex project comes with a dashboard. So you can go into it and you can go in and edit the data inside the table, and it instantaneously reflects on the UI because that's how Convex works. But now that I've updated the name of this score here, watch what happens if I try and delete this row now. Bam, error. The issue is that our aggregate has now gotten out of sync with our leaderboard. But Mike, why? We've just used triggers. Why? How has it got out of sync? You told me that it was going to be automatically kept in sync. Yeah, well, unfortunately, triggers don't work when you make changes to the data from the Convex dashboard. And right now, unfortunately, there is no workaround this. You just have to be really careful. Make sure that if you're going to change data through the dashboard, that you also remember to either update the aggregate component or resync it or something like that. We have been talking internally about ways to fix this, maybe with platform level triggers. So the dashboard would also cause triggers to be fired. But unfortunately, that's probably going to be a little bit way off before we get to a solution there. If you're keen to see a proper solution to this being developed, then leave me a comment down below and we'll see if we can bump up the priority on that. So hopefully at this point, you should have a good idea what the aggregate component is and how you can use it in your own project. But what happens if you have some existing table with some data in it already that you want to incorporate into your component? How can you go about adding the aggregate component on after the fact? Well, to solve that issue, we can pull in another component, the migrations component. We can then create a migration that will iterate over every row in the leaderboard table, for example, and populate our aggregate in a safe way. If you're interested more in this, then I recommend you check out the documentation, as there's full step-by-step instructions of the sequence that you should follow. Okay, so now if you're anything like me, you're probably wondering at this point, how is this wizardry performed? Well, I started to go deep on this topic and put together a whole demo that shows how the data structure evolves over time as you add and remove items. But the hours started turning into days, so I had to reluctantly park this project for now. But if you would like me to spend some more time on this and continue on this demo or dive a bit deeper into this topic in the future, then leave me a comment down below. But having said that, the TLDR is that the aggregate component works by storing the data in a really efficient data structure called a balanced search tree or B tree. This is a similar data structure that you might find in a regular database like Postgres and MySQL as an index. So what we are effectively doing is building an index that we can control inside of a Convex table. So by constructing this B tree in the Convex database, we can turn what would be O to the N operation into an O to the log N, which is obviously much more efficient. All right, so I promised a spicy take at the start of this video, so here it is. Convex chose explicitly not to offer aggregates in their core offering and instead offload it into userland or components like this one for some very good reasons that I elaborate in my dedicated video on the topic. By making users handle the aggregation of the data themselves, rather than leaving it up to the whims of the almighty query planner, you end up with a more predictable performance and cost. On the other hand though, it is more work to manage these simple counts and other basic aggregations yourself, manually via code or via the usage of this component. And unless you use triggers, it's very easy to forget to update the aggregate component when you make a mutation to the underlying data, which would leave your component in a corrupted state, and you would basically have to migrate your way out of it. Or worse, one of your teammates could change a value in the dashboard, as I showed earlier in this video, that would leave your component again in a corrupted state. These kinds of easy to make mistakes is, in my opinion, antithetical to the typical ethos of the no foot guns found in the rest of Convex. So I do wonder whether there's something that Convex should do more here. Maybe bringing some of the aggregations to the platform level, or maybe make the platform work better with triggers or something like that. Well, anyways, let me know what you guys think down below. I'm keen to hear what you think about this. Righto, that's just about it for me for today. I hope you enjoyed this video, and if you did, please leave me a like and sub. And if you wanted to check out another video a bit like this one, then you might want to check out this one I did a while back on embeddings and vector search. I dressed up as a schoolgirl. It was kind of fun. Anyways, until next time, thanks for watching. Cheerio. All right, so hopefully at this point, you should have a good idea of what the aggregate... Hopefully you have a good idea of what the aggregate... You should have a good idea of what the aggregate...